Model selection in Navure version 2.8. When fitting a model with many predictors, the question is how many of them are necessary. If the number of predictors is too large, methods such as lasso or ridge regression are good options. However, if the number of predictors allow fitting the model to include all predictors, there are alternatives within the framework of classical linear models like regression. Navure 2.8 implements two such algorithms, backward elimination and best subset selection. To illustrate this procedure, open the growing pasture test dataset in the test data repository. It contains 4 columns: treatments, plot, time, and growth. These data summarize the results of an assay in which 5 plots for each of 2 treatments were monitored 9 times to record pasture growth, with measurements taken approximately once per week. To get an idea of what we want to model, we will create a scatter plot of growth versus time, divided by treatments. Go to the Graphics tab, press the Scatter Plot button, select growth as the Y variable, time as the X variable, treatment as the partitioning criteria, and press the Run button, a blue arrow in the upper left corner of the dialog. There are 2 sets of points corresponding to treatments A and B, with the points for treatment B, the darker points, positioned above those for treatment A. To explore alternative fittings visually, select both series, navigate to the Curves and Connectors tab, and enable Show Smooth option on the left. This will display 2 lines, though they do not accurately represent the shape of the point cloud. Next, try the Polynomial fitting option. A second-order polynomial improves the curve, but a third-order polynomial provides a much better fit. While nonlinear sigmoidal models, e.g. logistic, would more accurately describe the growth curves, the third-order polynomial is sufficient for this illustration. Now we are going to fit a third-order polynomial regression, including treatments. Since the growth was measured several times on the same plot, we need to include a random effective plot to account for the lack of independence among observations on the same plot. Go to the Univariate tab and press the Mixed Linear Models button. In the Emerging dialog, drag growth to the Response Variable list, Treatment and Plot to Classification Factors list, Time to the Covariate list, and finally press the Run button. In the dialog box that appears, select Time from the list on the right and click the square X icon. A new dialog will prompt you to specify the degree of the polynomial. Enter 3 and confirm. This action adds new elements to the right list, representing time raised to the 2nd and 3rd power. These new elements, along with time, are also added to the list of fixed terms. Since we have a treatment factor that can define different growth curves, we need to include the appropriate interactions. Select treatment, time, and the new elements, then click the Interaction button in the Fixed Terms panel. This will add treatment and its interactions with time and its polynomial terms. At the bottom of the Fixed Terms panel, you will find a drop-down menu offering several selection methods. These methods are variations of 2 primary algorithms, backward elimination and best subset selection. Backward elimination variations depend on the p-value threshold used to remove terms. Best subset selection relies on criteria such as AIC or BC to compare subsets of terms. Let's proceed with best subset selection using BC as the ordination. Before proceeding, click the Random Terms item in the list at the left. Now double-click Plot in the right list to add Plot as a random term. Press the OK button. While best subset selection is a highly effective method, it can become computationally intensive when the number of potential models to evaluate grows too large. The results present the best 3 models ranked by BC. The first model was chosen for further analysis. In this model, the interactions between treatment and the 2nd and 3rd powers of times were excluded. Observations. The original model was estimated using restricted maximum likelihood, RML, but model selection methods need to use maximum likelihood, ML, for comparing models with different fixed terms. After choosing a model, Refit it with our email if you are interested in random parameters, noting that the ANOVA table will vary by estimation method. Finally, because this dataset has replicates for the different values of time, you can try a lack of fit test to confirm that the way you model the relationship between growth and time is adequate. To get this analysis, navigate to the Univariate tab and press the Mixed Linear Models button. In the emerging dialog, all settings are already done. Press Run, and in the emerging dialog, do not change anything but got to the Output Report tab. Click the Lack of Fit Test checkbox and press OK. Remember that the model selection will take place again. Below the analysis of variance table, you'll find the lack of fit result, which is not significant, indicating that the reduced model is good enough.